Here are the solutions to the mathematical methods written examination 1, 2021 for VCAA for the Northern Hemisphere. Question 1. Part A. Find the derivative of e to the power of 2x all divided by 2x plus 1. We are going to use the quotient rule, which says if y equals u over v, then dy dx equals u dash v minus uv dash over v squared. So we let u equals e to the power of 2x. This means that u dash equals 2e to the power of 2x. And we let v equals 2x plus 1, which means that v dash equals 2. Let's put all of this together. So dy dx equals 2e to the power of 2x times 2x plus 1 minus 2e to the power of 2x. And all of this is divided by 2x plus 1 all squared. Let's expand the brackets at the numerator. Notice how the last two terms at the numerator are the same. One is positive, one is negative, so they cancel out. So the answer is 4x e to the power of 2x all divided by 2x plus 1 all squared. Part B. Consider the function f of x equals sine to the power of 4 of 2x. The question is asking to evaluate f dash of pi on 4. First, determine f dash of x using the power rule and the chain rule. F dash of x equals 4 sine to the power of 3 2x times cos 2x times 2 equals 8 sine to the power of 3 of 2x cos 2x. We now substitute pi on 4 for x. Notice how 2 and 4 in both brackets cancel out. So the answer is 8 sine to the power of 3 of pi on 2 cos pi on 2. Notice that from the sine graph, sine of pi on 2 equals 1. And from the cos graph, cos of pi on 2 equals 0. So we substitute these two values into f dash of pi on 4. So we have 8 times 1 to the power of 3 times 0, which is 0. Question 2. Consider the function h of x equals x cubed log in base e of 2x. Part A. Show that h dash of x equals 3x squared log in base e of 2x plus x squared. We are going to use the product rule here, which says that if y equals uv, then dy dx equals u dash v plus uv dash. Let u equals x cubed, therefore u dash equals 3x squared, and let v equals log in base e of 2x, which means that v dash equals 2 times 1 over 2x equals 1 on x. So h dash of x equals 3x squared times log in base e of 2x plus x cubed times 1 on x. We simplify this, and h dash of x equals 3x squared log in base e of 2x plus x squared. Part B. Let dy dx equals 3x squared log in base e of 2x. The graph of y passes through the point with coordinates a half and negative 25 on 24. Find the rule of y. From part A, we know that integral from h dash of x dx equals h of x. We substitute these two functions with their expressions. And then on the left-hand side of this equation, we separate the two terms into two different integrals. We move the second integral on the right-hand side of the equation. And we know that y equals integral of 3x squared log in base e of 2x dx. which equals x to the power of 3 log in base e of 2x minus integral of x squared dx. Integral of x squared dx equals 1 on 3x cubed plus c. Let's substitute the coordinates of the point given into the equation above. And now we are going to solve this equation for c. Remember that log in base in any base of 1 is equal to 0. So c equals -1. So we can write that y equals x to the power of 3 log in base e of 2x minus 1 on 3x cubed minus 1. Question 3. Steffi is raising money for her school with a lucky dip game. In this game, 100 identical cubes numbered 1 to 100 are placed in a large container. The container is then thoroughly shaken. A player pays $2 and is blindfolded so they cannot see. The player then selects a cube at random. If the number on the selected cube is a multiple of 10, the player wins a cash prize of $7. The cube is then returned to the container, which is thoroughly shaken again before the next player makes a random selection. Each selection is independent of previous selections. Part A. Find the probability that the player will win a cash prize of $7. There are 10 numbers that are multiples of 10, 10, 20, 30, 40, 50, 60, 70, 80, 90, and 100. So this probability equals 10 over 100, which is 0.1. Part B. What is the expected loss to a player per game? There are two outcomes. Remember that the player has to pay $2 to play the game. So if the player wins $7, that means that he actually wins $5. And then if the player loses, then there is a loss of $2. The probability of a win is 0.1. The probability of a loss is 0.9. So the expected value is equal to 0.1 times 5 plus 0.9 times -2 equals -1.3. So the expected loss is $1.30. Part C. P hat is the random variable that represents the proportion of games won by a player in random samples of 3 games played. Find probability of P hat equals 2 over 3. This is a binomial distribution with the probability of success 0.1 and number of trials 3. So probability of x equals 2 equals combinations of 3 taken 2 at a time times 0.1 squared times 0.9, and this equals 0.027. So the probability of P hat equals 2 over 3 is 0.027. Question 4. Consider the two functions f of x equals 2e to the power of x plus 1 and g of x equals log in base e of x plus 2. Part AI. Find f of g of x in the form ax plus b, where a and b are real numbers. So let's substitute g of x for x, that equals 2e to the power of log in base e of x plus 2 plus 1. Remember that e to the power of log in base e of x plus 2 equals x plus 2. Therefore, f of g of x equals 2 bracket x plus 2 plus 1. We expand the brackets and this gives us 2x plus 5. Part 2i. State the range of f of g of x. Since the domain of g is -2 to infinity, then we need to calculate f of g and -2. And that equals 2 times -2 plus 5 equals 1. So the range of f of g of x is 1 to infinity. Part B. Consider the transformation given and let the graph of the function h be the transformation of the graph of the function g under t. If h is the inverse function of f, then find the values of c and d. First, let's determine the expression for h. So we swap x and y in f of x. And then we rearrange to make y the subject. This means that y equals log in base e of x minus 1 all divided by 2. Since h equals f2 minus 1, then h equals log in base e of x minus 1 all divided by 2. Or log in base e of x minus 1 minus log in base e of 2. We are going to rearrange the first log, so that equals log in base e of x plus 2 minus 3 minus log in base e of 2. So c equals negative 3 and d equals negative log in base e of 2. Or d equals log in base e of 1 over 2. Remember that c and d are the translations. Question 5. Part of the graph of f with domain negative infinity to negative 1, union 2 to infinity, has the rule f of x equals minus 2 sine pi x plus 1 is shown below. Let g of x with the same rule as f of x, but with domain from minus 1 to 2 closed interval. Part A. Sketch the graph of g on the axis provided above. First, we need to calculate the values of g at the end points. So g of minus 1 equals 1, and g of 2 equals also 1. Since g of x has the same rule as f of x, the shape of the graph is going to be the same. Part B. Find the solutions to g of x equals 0. So we have negative 2 sine pi x plus 1 equals 0. We subtract 1 from both sides of the equation. So we have negative 2 sine pi x equals negative 1. We divide both sides of the equation by negative 2. So we have sine pi x equals 1 on 2. The reference angle is pi on 6. Therefore, pi x equals pi on 6, or 5 pi on 6. We divide both sides of the equation by pi. Therefore, x equals 1 on 6 and 5 on 6. Part C. Find the area of the region bounded by the graph of g and the x-axis. Here is this region shaded from 1 on 6 to 5 on 6. To calculate the area, we need to calculate integral of g of x dx from 1 on 6 to 5 on 6. However, the region is under the x-axis, so we have to put either a negative sign in front of the integral or we swap the terminals. We are going to swap the terminals here from 5 on 6 to 1 on 6. We do the integral and then we substitute the two terminals. And then we simplify. And this gives us the answer 2 root 3 on pi minus 4 on 6. We cancel down 4 on 6, so we have 2 root 3 on pi minus 2 on 3. Question 6. Let A and B be events for a sample space such that probability of A equals 2 on 3, probability of B given A is 2 on 5, and probability of B given A dash equals 1 on 4. Part A. Find the probability of B. Let's draw a Venn diagram. A circle for event A and a circle for event B. The part in the middle, the overlap, is A intersection B, and the remainder of the circle for event B is A dash intersection B. So probability of B equals probability of A intersection B plus probability of A dash intersection B. We know that the probability of A intersection B equals probability of A times probability of B given A, and probability of A dash intersection B equals probability of A dash times probability of B given A dash. We substitute the values we know and we calculate, and the answer is 7/20. Part B. Find probability of A dash union B dash. Now, again, a Venn diagram. This is the circle for event A, and outside is A dash. Similarly, we have the circle for event B, and outside is B dash. We put these together, and the shaded region represents A dash union B dash. So the probability of A dash union B dash equals 1 minus probability of A intersection B. Therefore, this equals 1 minus 4/15, which is equal to 11/15. Question 7. Consider the function q with domain from 0 to 4 closed interval, given by the rule x bracket 4 minus x. A rectangle ABCD is inscribed between the graph of the function q and the x-axis. Its vertices are A units, where A is greater than 0, from the axis of symmetry x equals 2, as shown below. Part A. Find the value of A when the rectangle is a square. Give your answer in the form B plus square root of C, where B is an integer and C is a positive integer. Since this rectangle is a square, then AB equals BC. AB equals OB minus OA equals 2 plus A minus bracket 2 minus A, close bracket. If we expand the brackets, that gives us 2A. BC is going to be Q of 2 plus A. So we substitute 2 plus A into the function Q of x. And we end up with BC equals 4 minus A squared. So we equate the two lengths. 2A equals 4 minus A squared. And we obtain the quadratic equation A squared plus 2A minus 4 equals 0. We are going to use the quadratic formula to calculate the value of A. And that is -1 plus or minus square root of 5. Now remember, the question said A greater than 0. Therefore, A is equal to -1 plus root 5. Part B. Find the maximum area of the rectangle ABCD. Give your answer in the form m square root of n all over p, where m, n, and p are positive integers. The area of the rectangle is AB times BC, which is 2A times bracket 4 minus A squared. That gives us 8A minus 2A cubed. For the maximum area, the derivative of the area with respect to little a equals 0. dA by dA equals 8 minus 6A squared. And this equals 0. Therefore, A equals 2 over root 3. To calculate the maximum area, we need to substitute this value into the formula for the area of the rectangle. And we calculate it as 32 root 3 over 9. Question 8. The graph of the function with domain is from 0 to 4 closed interval f of x has rule x bracket 2 minus root x, and part of the graph of g with domain 0 to infinity and rule g of x equals 2x are shown below. Part A. Find f dash of x. Let's expand the brackets in f of x and rewrite the square root as a power. So f of x equals 2x minus x times x to the power of a half. We simplify this, and f of x equals 2x minus x to the power of 3 on 2. We can now differentiate, so f dash of x equals 2 minus 3 on 2 x to the power of a half. Part B. The tangent to the graph of f at the point B with coordinates b and f of b is perpendicular to the graph of g. Find the coordinates of b. Let's draw this tangent perpendicular to g, and here is point B on the graph of f. The gradient of the tangent to f at b equals f dash of b. Therefore, f dash of b equals 2 minus 3 on 2b to the power of a half. Since the gradient of g is 2, then the gradient of the tangent is negative 1 on 2. Therefore, we can write that 2 minus 3 on 2 b to the power of a half equals negative 1 on 2. We subtract 2 from both sides of the equation, so we have negative 3 on 2b to a half equals negative 5 on 2. We multiply both sides of the equation by negative 2, and we end up with 3b to the power of a half equals 5. Divide both sides of the equation by 3, so b to the power of a half equals 5 on 3. We square both sides of the equation, which gives us b equals 25 on 9. Now we calculate f of 25 on 9, and that gives us 25 on 27. So the coordinates of point B are 25 on 9 and 25 on 27. Part C. Show that the graphs of f and g intersect only at the origin. For this, we need to equate the two functions. 2x minus x root x equals 2x. We subtract 2x from both sides of the equation, and we have x root x equals 0, which means that x equals 0. That is the only point of intersection. Part D. Let Q with coordinates q to q, where q is greater than 0, be a point on the graph of G. The tangent to the graph of f at the point D with coordinates d and f of d passes through q as shown below. It can be shown that d equals 3q. Determine the values of q for which the tangent to the graph of f passes through q and has an x-axis intercept greater than 4. Since the x-intercept of the tangent is greater than 4, then d must be less than 4. Remember that d equals 3q, so 3q is less than 4, which means that q is less than 4 on 3. To keep the x-intercept of the tangent greater than 4, the gradient of the tangent must be less than 0. Therefore, f dash of x less than 0. That means 2 minus 3 on 2 x to the power of a half is less than 0. We subtract 2 from both sides of the equation, and then we multiply the equation by 2 and divide by 3. So we have x to the power of a half greater than 4 on 3. We can now square both sides of the equation, so x is greater than 16 on 9. This implies that d is greater than 16 on 9. Remember again, d equals 3q, so 3q is greater than 16 on 9. So q is greater than 16 over 27. So q is an element of the interval 16 on 27 to 4 on 3. Both ends of the interval are open. Question 9. A differentiable function f has the following two properties. F dash of x equals f of x bracket 4 minus f of x, and the range of f is 0 to 4, open brackets. Part A. Find f dash of 0 if f of 0 equals 1. So we substitute f of 0 with 1 in the equation of f dash of 0. And that gives us the value 3. Part B. Determine with appropriate justification the number of stationary points of the graph of f. Stationary points occur when f dash of x equals 0. Therefore, f of x bracket 4 minus f of x equals 0. We use the null factor law, which means that f of x equals 0 or 4 minus f of x equals 0. So f of x equals 0 or f of x equals 4. Since the range of f is from 0 to 4 open ends, there are no stationary points because f of x cannot be equal to 0 and f of x cannot be equal to 4. Part C. State the range of f dash. When f of x approaches 0, f dash of x approaches 0 as well. When f of x approaches 4, f dash of x approaches 0. F dash of x equals f of x bracket 4 minus f of x. We can expand the brackets and we obtain a quadratic, 4f of x minus f of x all squared. This quadratic has a turning point when f of x equals 2 and f dash of x equals 4. So the maximum value of f dash of x is 4. Therefore, the range of f dash of x is 0 to 4, 0 open end, 4 closed end.